All right, hello. Welcome to my channel. This is an educational channel. We learn about various different things on this channel, mostly things that are on the esoteric and obscure side. And today is the 144th video that we've done on the Tree of Life. We have done 144 videos on the Tree of Life also, but these are 144 videos on the reciprocal system of theory. And this is a theory that was first invented by Dewey B. Larson in the 20th century. And it is a theory of everything. It's a system of theory, meaning that you can learn the system and you can apply it to any subject and every subject. And the basic gist is that the universe is a universe of motion. Not a universe of matter or a universe of energy, but a universe of motion. Matter and energy are just kinds of motion. And motion is the relationship between space and time. Space and time have a generalized reciprocal relationship. And they don't really exist, only together in motion. Larson took that basic postulate along with another that had to do with the nature of math and geometry, and he derived an entire theoretical universe about what exists in his universe, and then he compared that to the kind of empirical universe that the scientists have been uncovering through their measurements and experiments. And unfortunately, sometimes their theories also. And, in Larson's system, 9/10 of what the scientists had come up with fit in seamlessly with his system. And just like Einstein's system, the areas of disagreement were all areas on the margins. The relativistic areas, very fast, the very slow, the very small, and the very large. The same kind of corrections that Einstein, his theories of relativity, did to the Newtonian universe. In fact, Larson has a book that is called Beyond Newton, because that's where he takes his launching point, not from Einstein, but from Newton, just like Einstein did. Okay, now we are looking at his 1979 book called Nothing But Motion. And this is a book about physics and mostly physics. There's some stuff at the end on organic chemistry also. But Larson also has books on chemistry and astronomy and economics and metaphysics, including religion and philosophy and psychology, dream interpretation, all kinds of stuff. Some of his colleagues or successors have also written books on other subjects. We'll be dealing with those as we move along. There's a lot here. I'm just kind of intending to create it, really like a reciprocal system library of videos that cover all of the most influential videos, the ones that I think that can benefit people the most. And so that's why we've done so many videos, and we're going to do so many more on the reciprocal system. I study, in general, many different theories of everything, but the reciprocal system is one of the best that I've encountered. But I will probably have more to say about that later in regards to a few things that Larson has said in this book so far. But we are toward the end of chapter 3, and he was talking about extension space and how that is this chapter is called reference systems, and this is a key chapter to understand. This is where Larson lays out his basic theoretical pinnings, and we'll just start right here. Now, just remember that in Larson's universe, in the legacy science universe, space and time are the container of the universe. They contain whatever is going to go on in the universe. It's in space and in time. For Larson, space and time are not the container, but the contents of the universe. They are what the universe is actually made out of. Space-time being motion. Time-space is also what time-space is energy, which is also a kind of motion. Space-time is speed, and time-space is energy. Okay. And sorry to keep digressing, but space over time is speed. Time over space is energy. Okay, extension space, the container visualized by most individuals when they think of space, is capable of representing only translational motion, its spatial aspect, not physical space in general. But the spatial aspect of any motion has the same relation to the physical phenomena in which it is involved as the spatial aspect of translational motion. That we can follow by means of its representation in the coordinate system. For example, the space involved in rotation is physical space, but it can be defined in the conventional reference system only with the aid of an auxiliary scalar quantity, the number of revolutions. By itself, that reference system cannot distinguish between one revolution and n revolutions, nor is it able to represent vibrational motion. As will be found later in the development, even its capability of representing translational motion is subject to some significant limitations. Regardless of whether motion is translatory, vibratory, or rotational, its spatial aspect is space from the physical standpoint. And whenever a physical process involves space in general, rather than merely the spatial aspect of translational motion, all components of the total space must be taken into account. The full implications of this statement will not become apparent until we are ready to begin consideration of electrical phenomena, but it obviously rules out the possibility of a universal reference system to which all spatial magnitudes can be related. Furthermore, every motion, and therefore every physical object, a manifestation of motion, has a location in three-dimensional time as well as in three-dimensional space. And no spatial reference system is capable of representing both locations. It may be somewhat disconcerting to many readers to be told that we are dealing with a universe that transcends the stationary three-dimensional spatial reference system in which popular opinion places it. A universe that involves three-dimensional time, scalar motion, a moving reference system, and so on. But it should be realized that this complexity is not peculiar to the reciprocal system. No physical theory that enjoys any substantial degree of acceptance today portrays the universe as capable of being accurately represented in its entirety within any kind of a spatial reference system. Indeed, the present-day official school of physical theory says that the basic entities of the universe are not objectively real at all. They are phantoms, which can only be symbolized by partial differential equations in an abstract multidimensional space. And that latter was a quote from Werner Heisenberg. Prior to the latter part of the 19th century, there was no problem in this area. It was assumed without question that space and time were clearly recognizable entities, that all spatial locations could be defined in terms of an absolute spatial reference system, and that time could be defined in terms of a universal, uniform flow. But the experimental demonstration of the constant speed of light by Michelson and Morley threw this situation into confusion, and from which it has never fully emerged. The prevailing scientific opinion at the moment is that time is not an independent entity, but is a sort of quasi-space existing in one dimension that is joined in some manner to the three dimensions of space to form a four-dimensional continuum. Inasmuch as this creates as many problems as it solves, it has been further assumed that this continuum is distorted by the presence of matter. These assumptions, which are basic to, in relativity theory, the currently accepted doctrine, leave the conventional spatial reference system in a very curious position. Einstein says that his theory requires us to free ourselves, quote, from the idea that coordinates must have an immediate metrical meaning, end quote. He defines this expression, a metrical meaning, as the existence of a specific relationship between differences of coordinates and measurable lengths and times. Just what kind of a meaning the coordinates can have if they do not represent measurable magnitudes is rather difficult to understand. The truth is that the differences in coordinates, which according to Einstein have no metrical meaning, are the spatial magnitudes that enter into almost all of our physical calculations. Even in astronomy, where it might be presumed that any inaccuracy would be very serious, in view of the great magnitudes involved, we get this report from Hannes Alfvén. Quote, the general theory of relativity has not been applied to celestial mechanics on an appreciable scale. The simpler Newtonian theory is still employed almost exclusively to calculate the motions of celestial bodies. End quote. Our theoretical development now demonstrates that the differences in coordinates do have metrical meaning, and that wherever we are dealing with vectorial motions or with scalar motions that can be referred to identifiable reference points, these coordinate positions accurately represent the spatial aspects of the translational motions that are involved. This explains why the hypothesis of an absolute spatial reference system for the universe as a whole was so successful for such a long time. The exceptions are exceptional in ordinary practice. The existence of multiple reference points has had no significant impact except in the case of gravitation. And the use of the force concept has sidestepped the gravitational issue. Only in recent years have the observations penetrated into regions outside the boundaries of the conventional reference systems. But now we have to deal with the consequences of this enlargement of the scope of our observations. In the course of the present work, it has been found that the problems introduced into physical science by the extension of experimental and observational knowledge are directly due to the fact that some of the newly discovered phenomena transcend the reference systems into which current science is trying to place them. As we will see later, this is particularly true where variations in time magnitudes are involved, inasmuch as conventional spatial reference systems assume a fixed and unchanging progression of time. In order to get the true picture, it is necessary to realize that no single reference system is capable of representing the whole of physical reality. I guess that makes sense, but it seems like it is an assumption. Okay, back to Larson. The universe, as seen in the context of the reciprocal system of theory, is much more complex than is generally realized. But the simple Newtonian universe was abandoned by science long ago, and the modifications of the Newtonian view that we now find necessary are actually less drastic than those required by the currently popular physical theories. Of course, in the final analysis, this makes no difference. Scientific thought will have to conform to the way in which the universe actually behaves, irrespective of personal preferences. But it is significant that all of the phenomena of a universe of motion, as they emerge from the development of the reciprocal system, are rational, clearly defined, and objectively real. Okay, so that's the end of the chapter 3 on reference systems. So, I think at the end he makes an important point that people are objecting to Larson's reciprocal system because of the unfamiliarity and the kind of caveats that it has to make from the Newtonian universe. And what he's pointing out is that these differences that are needed to be made in the reciprocal, in the Newtonian theory that the reciprocal system provides, are less drastic than the relativistic or quantum mechanical changes that have already been accepted. Larson's system is less complicated and less of a change from Newtonian mechanics as the relativity theory. But people, and people, I suppose people probably had a lot of trouble with the relativity theory when it first was coming online, but the scientists are pretty much all on board with that at this point. But I guess that they're probably angry because they had to adjust their theories to fit the Einsteinian paradigm, and now that's falling a little bit short, and they're not wanting to retool again, and so they're just kind of rejecting Larson's theory out of hand, where what it requires is just to give it a hearing, now, you don't have to accept every finding that Larson comes up with. And he doesn't say that. He says that the system is correct. Whether I have applied it correctly is a different question. And he made some mistakes in the application of the theory. But the theory itself, he says, is correct. And that nothing has come along to disprove that. Okay, now we're going to just read a couple paragraphs here of chapter 4. Chapter 4 is called Radiation. The basic postulate of the reciprocal system of theory asserts the existence of motion. In itself, without qualification, this would permit the existence of any conceivable kind of motion, but the additional assumptions included in the postulates act as limitations on the types of motion that are possible. The net result of the basic postulates plus the limitations is therefore to assert the existence of any kind of motion that is not excluded by the limiting assumptions. We may express this point concisely by saying that in the theoretical universe of motion, anything that can exist does exist. And I think that's the philosophical principle of plenitude. Anything that can exist does exist. Anything that is not forbidden to exist does exist. The further fact that these permissible theoretical phenomena coincide item by item with the observed phenomena of the actual physical universe is something that will have to be demonstrated step by step as the development proceeds. Some objections have been raised to the foregoing conclusion that what can exist does exist, on the ground that actuality does not necessarily follow from possibility. But no one is contending that actual existence is a necessary consequence of possible existence as a general proposition. What is contended is that this is true for special reasons in the physical universe. Philosophers explain this as being the result of a principle of nature. David Hawkins, for instance, tells us that the principle of plenitude says that all things possible in nature are actualized. What the present development has done is to explain why nature follows such a principle. Our finding is that the basic physical entities are scalar motions, and that the existence of different observable entities and phenomena is due to the fact that these motions necessarily assume specific directions when they appear in the context of a three-dimensional frame of reference. Inasmuch as the directions are determined by chance, there is a finite probability corresponding to every possible direction, and thus every possibility becomes an actuality. It should be noted that this is exactly the same principle that was applied in Chapter 3 to explain why an expanding sphere of radiation emanates from each radiation source. Okay, I'm just going to leave it there. We'll start up again tomorrow. Thanks for tuning in.